Every program works with data, but how does a processor know how much data to load, store, or interpret? In ARM systems, understanding data types and memory layout is the foundation of writing correct and efficient low-level code. Let's break it down step by step. At high level, programming languages define different data types, such as integers and real numbers. Some languages assign these types automatically, but at the hardware level, what really matters is size. Values can be stored as positive integers, signed integers, or real numbers, and each value requires a specific number of bytes in memory. Common data sizes include 8-bit, 16-bit, 32-bit, and 64-bit values. In ARM, AR64 architecture, registers are either 64-bit or 32-bit wide. Instructions like LDR and SDR load data from memory into a register or store data from a register back to memory. When using these instructions, the entire register is loaded or stored. That means 64-bit registers move 8 bytes at once, while 32-bit registers move 4 bytes. Even if you only care about a smaller value, the full register operation still takes place. To work with smaller values, ARM provides specialized instructions. LDRB loads a single byte and LDRH loads a half word. For single values, instructions like LDRSB and LDRSH perform sign extensions. These instructions can only write to 32-bit registers. That's because ARM only supports sign extension in 32-bit registers, and any write to a 32-bit register automatically clears the upper 32 bits of the 64-bit register. Another important concept is NDNS. NDNS defines the order in which bytes are stored in memory. In little endian format, the least significant byte is stored first. In big endian format, the most significant byte comes first. ARM v8 processors support both modes, depending on the processor features and system configuration. In practice, most software today uses little endian format. However, network protocols like TCP/IP and some file formats such as JPEG and TIFF use big endian byte order. Because of this, developers must always be aware of how data is stored and transferred. Understanding data sizes, register behavior, and NDNS gives you precise control over how data moves through an ARM system. These fundamentals are essential for low-level programming, debugging, and performance optimization.